Hello guys, so I welcome you all in a Sapience education. So today I am going to cover the following topics: gravitational field, gravitational potential difference, and gravitational potential as well as gravitational potential energy. So as you know that if you will go for class 12, so all this topic will be similar. Like for example, if in place of gravitational, it will be replaced by electrical potential, electrical potential energy and all, electrical field. You need to understand this thing. So if the concepts will be clear for this four topic, then definitely it will be very helpful for class 12. Okay, so I hope you have understood why I am focusing this chapter. So try to understand each and every topic one by one. Okay, so let us consider there is a gravitational field. What is gravitational field? The space surrounding a material body in which gravitational force of attraction can be experienced is called as gravitational field. For example, let us consider there is a one object. It is one object, okay, which has a mass m, and around this, if any other mass will be placed, so it will experiences some forces due to this mass, right? It means that it has some field around it. Understood or not? But the thing is that whenever single mass cannot experience a gravitational field. Okay, so to need if you want gravitational force to be experienced, there is a need of two mass. Okay, there is a need of two mass. I hope you have understood. Now, what is gravitational field intensity? So again, I am telling you that this is an object. So area or space around it, where another mass will experiences a force due to this body, then that area is called gravitational field. Okay. Now, gravitational field intensity. It is defined as the gravitational force experienced by unit mass placed at any point in a gravitational field. Intensity. How much force a unit mass means 1 kg mass experiences how much force, and that is called a gravitational field intensity. Okay, for example, there is a 4 kg mass and it experiences a force of 500 newton. So how much force will be experienced by 1 kg? So it will be 500 newton divided by 4, right? So this will be divided by this quantity is called gravitational field intensity. Intensity is defined as the gravitational force experienced by a unit mass. Only one unit mass I am talking about. So I hope you have understood now. Now let us see here. If you mathematically you want, see here. Suppose there is a source. There is a source of a mass. So this is a mass source and this is your test mass. Test mass means what? 1 kg mass. I am talking about 1 unit mass. Okay. So here what is intensity is your force by total mass. That is force has definition G m capital M small m by r square, as we have discussed in gravitational constant and gravitational law of Newton's law of gravitation. So please divide it by m. So m got cancelled out. So you will get G m by r square, and this is called the intensity. This is the mathematical model of intensity. Now if you want in a vector form, so I intensity will be minus Gm by r square into r vector. It is always toward the center of the gravity and whose intensity is to be considered. Okay, it is always toward the center of gravity. Okay, for example, I am considering this mass and I want the intensity by this mass. Then the force direction of intensity will be toward this mass only. So it is always toward the center of gravity of whose intensity is to be considered. Okay, so this is what I am talking about, intensity of the gravitational field. Now let us define gravitational potential difference. See, one most important thing I want to talk here. Everywhere, what is happening? Everywhere, what is happening? Let us. Okay. Now, gravitational potential difference. It is defined as a work done. So before this, I want to discuss that why I am talking about potential difference first. Earlier in class 10, always you have studied in electric chapter that potential difference. You haven't studied about potential. Actually, in physics, we always talk about potential difference only. So for potential difference, we need some reference point. We need some reference point. Okay. So that's why first of all I will talk about a potential difference. Okay. So first of all I will talk about potential difference. Understood? Now it is defined as the work done to move a unit mass from one point to another in a gravitational field without changing kinetic energy. So let us consider there is a gravitational field having a point A and there is a point B, and a simple mass, any mass, if you bring mass from point A to point B to A, so you need work done from B to A. Okay. Then the potential difference will be equal to work done in bringing a mass m from B to A per unit mass divided by mass. So this is the mathematical model of the gravitational potential difference. Earlier it has some potential, for example UB, VB, or final potential is VA. So what is the potential difference? So potential difference will be final potential minus initial potential, and by using this you will able to find a potential difference. So this is a gravitational potential difference. Okay. Now what is gravitational potential? So it is the amount of work done in bringing a body of a unit mass from infinite to that point. Now see here, what is the basic difference? See, earlier what happened, I have considered two point A and B. Now in gravitational potential, actually it is gravitational potential is also a potential difference only, but the thing is that in reference point in place of a B, I am taking as infinity. I am taking as infinity. For example, there is a body of a mass m, okay, and due to this mass there is a potential, it is called VA, and there is another potential which is called VE. So whenever I will take this mass, small mass, to this place, so I have to do work. Then the work done per unit mass is known as potential difference between these 2 points, right? Okay. So suppose earlier it was R1, RA and RB is the distance. Now consider, I am considering this RB is to be infinite distance. So if it is infinite distance, so definitely potential VB will be 0, because at infinite distance there is no chance to experience a gravitational force, right? So if there is no gravitational force, so definitely we don't need the work. So now if you consider this, then you will get a potential. So it is the amount of work done in bringing a body of a unit mass from infinite to that point without changing kinetic energy. This is very important. You should not change any kinetic energy at all. How you will do this? Slowly you have to move. Slowly you have to move. You have to move. Right? And by doing slowly, you need a work. How? Let's discuss more in a more detailed manner. See, first of all, I will draw this. Okay, okay. Now, see here is there is a mass m, capital M mass, and there is a small mass m. Okay, there is a small mass. Is it visible? I hope it is visible now. This, see here. This is a small mass, okay, and this is a capital mass. This is your capital mass and this is your small mass. Okay. Now see here, you know that force there is which type of force there are attraction force. So if you release this mass nearby this, so what will happen? This mass will automatically come to this point. But the thing is that as soon as it will automatically come to this point, so there will be an acceleration. That will be there is a change in kinetic energy. But we don't want, right? And if we don't want, then we have to apply a force externally. And if you apply a force externally, then what will happen? It will be move. This body will move slowly. For example, see in a details. See in a details. Mm, Let us consider this. Please rub this. Uh, Now let us see here. There is a capital mass M, and there is a body having a small mass m. As there is a force of attraction, this is called force due to gravity, and due to this gravity, what will happen? There will be an acceleration. To avoid this acceleration, we need to apply an external force, right? And if you apply an external force, so what will happen? To move distance from infinity to this point, we have to do work. Whenever you are applying a force, external force, so you and there is a displacement, so what will happen? The work will be done. And see here, displacement is in this direction, but applied force is in this direction, so definitely work done will be negative. And due to this negative value, we are getting all the values negative in a gravitational potential. So let us see now. Let us see. I hope you have understood why I am telling again that why change in kinetic energy should be zero. And why we required external force, because as we leave this definitely, since here attractive force is there, so why should we apply a force? We should apply force to avoid acceleration, to avoid change in a kinetic energy, and from here to here, to avoid this, we have to apply external force. For example, gravitational force is being applied 100 newtons, so external force will be also being applied 100 newton in opposite direction. And if we do this, then what will happen? We have to apply, we have to do work, because work has a formula F into d F as cos theta. So here displacement is there, we are applying force, so definitely there will be a work is to be done. And as soon as this work is done, then this work is being converted into the potential energy at all. Okay, so see here. So again I'm trying to make it clear, right? Again I'm trying to make it clear. From infinite to that point without changing kinetic energy. Now let us see here. See here in diagram I have shown clearly that there is a capital mass M and there is a small mass which is present at infinity, right? I have to move this small mass at a point P, which is at a distance of r. Okay. Now we know the integration method. Let us consider any point which is at a distance of x. When we move this object, this mass from for this small displacement dx, so what will happen? We have to work. Okay. So we have to work. Now if you have to work, so when a mass is moved for dx, which was at a distance of x, then work done will be what? Work done will be W will be equal to integration of f dot dx, because there is a small displacement, and our target is to move an object from infinity to r distance. Now as we know that force is equal to minus g into m by x square into dx. Okay. Just now I I have done this just now. I have done this. Work done is always negative. So force is negative. Force is negative, right? Force is negative. So that's why cos theta is negative. For example, an object is being moved in this direction, but your applied force is in this direction. So work done has a negative sign. So that's why I have put this negative sign. So don't be confused. So as you know that force between two particle F is equal to G into M into small m by R square, and this is your gravitational Newton's law of gravitation. As as per Newton's law of gravitation, so I have kept like this. So as you integrate it, so what will happen? So negative sign G M into small m, the small m will be there, which is at a constant, and it will become x, and it is from infinity to R. So you should know about integration, so how you will integrate, because you need to actually integrate 1 by x square into dx. So if you will integrate it 1 by x square into dx, so what will happen? See here, let's see, this is not a minus sign. So this is not minus sign. So in place of force, you have to apply a g m capital M into small m by x square from infinity to R into dx. Okay. So here what will happen? Minus g into capital M into small m by x. If you will integrate this, you will get the value. So if you do this, so what will happen? Finally, you will get the answer minus g m by R. So that's why potential at a point P, that is work done from infinity to point P, divided by per unit mass. It should be per unit mass. So finally, if you will put all the value, so you will get potential at a point P. Okay. So potential at a point P is this is the definition. This is the definition of a potential at a point P and the numerical values. So now I am talking about gravitational potential energy. So what is gravitational potential energy? The gravitational potential energy of a body at a point is defined as the amount of work done in bringing the body from infinity to that point against the gravitational force. Earlier, in case of gravitational potential, we are talking about per unit mass, amount of work done in bringing per unit mass. But the thing is that when I am talking about gravitational potential energy, it is does not matter about mass, whatever it will be, maybe 5 kg, 2 kg. Whenever you will bring this mass from infinity to a point P, which is at a distance of R, so you will get the you have to spend a work, and this work is being converted into potential energy. That is the difference between potential and potential energy. So let us see how I have to do this. See here, this is a mass m, this is a mass m, and this is a capital mass M. Okay, and at infinity, this mass is infinity, and this mass does not have required any mass of 1 kg only. So if this mass is, for example, if this mass is being put here at a distance of x, and if I will move for a distance of dx, so what will happen? U is equal to work done from infinity to that point P, and that is from infinity to R, and force is equal to G into capital M into small m by x square into dx. So as you know that if gmm by gmm is your constant, so pick out outside. So 1 by x square has an integrated value as a minus 1 by x, and it is from infinity to R. Okay. So if you will finally solve this, so you will get this. So this has a value 0. So finally, potential energy is equal, U is equal to minus G into capital M small m by R square. So it is a scalar quantity. So I hope you have understood now how to find the potential energy. So what is the basic difference between potential energy and potential? See here, we have found B potential is equal to minus G m by R. But as soon as we are talking about potential energy, so we have to write G m small m by R. Okay, so this is the small m. So this is your per unit mass, and this is your included in a mass. So if you want to find a relation between these two, so how you will find relation between these two? See here, Vp is equal to U by mass. Okay, so potential energy can be written as mass into potential energy. This is the relation. Okay, see see, because potential has a formula, V is equal to minus G m by R. So from this you can find a relation, and you will get relation U is equal to m into Vp.
So I hope you have understood this. Okay, I hope you have understood this. And now as we know that potential energy is equal to minus gm by r, so it is always negative because force is always attractive in a nature. See here, whenever we are talking about masses, so there will be an attractive. So we have to always apply a force in opposite direction, and if you are applying a force in opposite direction of the displacement, so you will get work as a negative, and if that work is being converted into potential energy, so hence potential energy is a negative. Okay, so I hope you have understood now. Now if you want to find a potential energy potential energy due to system of mass, then how you will find? So let us consider there is a core system of masses and placed in the form of square or anything else, right? So this is your mass m, this is your mass m2, m1, m2, m3 and m4. So we need to find the potential in the pair and add on. So how you will find potential and add on? See here, u total is equal to potential of a body, potential between body of mass m1 and m2 plus potential of a mass m1 and m3 plus potential of a mass m1 and m4. Now potential at a mass 2 and 4, potential of a mass 2 and 3 plus potential of a mass 3 and 4. So if you will get each and every pairs of a potential, so you have to add on, so you will get directly total potential energy. So if you will able to solve, please try to solve NCRT question so that you will able to understood. It is very simple. Okay, and try to remember always this formula: potential is equal to minus z m with small m by r. And if this is your potential energy, and if you want to find potential, so this will be gm by capital M by r, and this is your minus. Okay, so use this formula to find out anything. Okay, so I hope you have understood now, and hope if you have any problem, please ask the query. Thank you.